Hi, my name is Steve Bjork. I'm the CTO and founder of MindTouch. And in this presentation, I will talk about how to build serverless .NET application on AWS using a tool called LambdaSharp that we use at MindTouch. So first provide a little introduction on LambdaSharp, as well as then actually show how to build an application of both frontend and backend, and then show the finished product and a little recap of what we built today. So LambdaSharp is a set of multiple components. Primarily, it's a CLI tool that you can use to build application more seamlessly for .NET on AWS. There's also an SDK component, which is used for the base classes on functions and so on, to just take on some common functionality for better observability and so on and so forth. We'll talk about that in a moment. And then lastly, there's a component called the module, which is a superset of CloudFormation templates. So there's some additional syntax and capabilities. And optionally, there's also a set of services that can be deployed as part of LambdaSharp that provide better observability. But ultimately, LambdaSharp's mission is to really create a streamlined experience for developers when building serverless .NET applications on AWS. And I hope to show that today. So for this talk, I wanted to build a complete application. And so this is fairly simple. It's kind of a Bitcoin hot or not, I labeled it. And it will fetch the most current Bitcoin price and then give users who have the application open the opportunity to either vote it up or down, depending if they like the price or not. All of this is orchestrated on the backend with a Lambda function, which we use for fetching the current Bitcoin price from an API. We then publish it on a regular schedule, like once a minute, onto Amazon EventBridge, and the frontend is subscribed to those events, so it receives them and can update itself. And similarly, when either an upvote or downvote comes in, that is sent to the backend as a CloudWatch event as well, which is then propagated to all open clients. So all the clients can see how many up and downvotes there were. And the whole application, backend and frontend, is all built with .NET Core. To get started, of course, you need an AWS account, but you also need the .NET SDK 3.1. You probably want an IDE of some sorts. And then lastly, you just need to get started with LambdaSharp. Installing the tool just takes one very simple command. And then you create a quick start deployment, which takes about 30 seconds. It creates an S3 deployment bucket for artifacts to be uploaded to. So without further ado, let's build the first part of this application, specifically the Lambda backend. So I have Visual Studio Code up here, and I have already LambdaSharp installed. The first step is to create a new module, which is this CloudFormation style template. It's a YAML file that describes your application and the components of it. It has a couple of additional capabilities, as well as metadata. In this case, I'm updating the description so that when it is deployed in CloudFormation, we have a better label for what it is. There's another command for adding a function. So this one, similar to creating the initial module YAML file, allows us to specify name, and then we know it's a scheduled function, runs once a minute, so we can select that as a template, and it creates the entire project and adds it also to the YAML file at the same time. So we see that here. The next thing is we probably want use a library to share code definition between the front and the back end of our application, because everything is written in C#. We use a class library for that. It gets added. And the first thing we need to do, of course, in order for this definition to become available is create a project reference from our Lambda function to our class library that we added. So I'm just going to duplicate an existing project reference and then update it to point to our new project. And then all definitions that we put into the class library file will become available to our Lambda function project as well. Okay, now that we have done that, let's build it and make sure that all the no typos, as well as have all the references being resolved correctly. The first part, there's two methods. The first one, initialize, we won't need it. The second one is a process event. That's the method that gets invoked whenever we get a scheduled event. Rather than to type all this code in, I prepared it in a separate README file. So let me copy that over and replace the body of the process event async method with this one. So we're going to we use HTTP client, we're going to this endpoint to fetch a JSON document that shows us the current Bitcoin price. It's a fairly simple data structure, and we want to get ultimately to this float that is the current price. Once we have fetched this JSON document and successfully, we need to parse it. And we parse it into a dynamic object, which allows us to effectively retrieve the value from it without having to define a full class. It's a little bit easier. So as you can see, now we can just dive right into it without having to have created the class definitions up front. So that gives us the price of for Bitcoin currently. The next thing is we need to publish that we have retrieved it. And for that, we need a simple C# class definition. And that one we want to share between the front and the backend. So now we're going to use our shared class library. We'll just quickly update the default class was created. And this is a very simple class definition. It has a single property price that we set. And then we use the log method call to have it emitted to EventBridge. And that's pretty much it coding-wise. We have to make sure we have the right username spaces. And here we go. We fetched the value. We have it set up here. Oh, we do need to make sure that we trigger this Lambda method now once per minute. So we subscribe it to a scheduled event. Our code is complete. Our CloudFormation code is in place. Now the step is just to have everything be compiled, uploaded, and deployed for us. And for that, LambdaSharp provides a simple command called deploy. And we can see how our stack is being now created. So this takes about 2 minutes. While that is happening, let's talk about what we just did. So on the left, we can see this is the module definition, the YAML file that we created. It contains a function name, which is also the name of the C# project that was created. So this tells the LambdaSharp tool what to compile and then eventually upload as an artifact. Everything gets converted into actual CloudFormation JSON that gets uploaded to CloudFormation service and then triggered. And this will take care of creating the IAM roles, the CloudWatch logs, the Lambda, of course, as well as the scheduled event that we had created initially. And that's it. Now we have a Lambda function that is fetching once per minute the price from the API and publishing on EventBridge. So we just need to subscribe to it and create a front end for it. So that's the next part we're going to dive into. So let's take a look at what that looks like. So similar to what we did with creating the function, creating a new app that gets attached to our module is very simple. We call it vote app, seems fitting. And again, it adds automatically the declarations to our CloudFormation. This is a Blazor WebAssembly application. We want to access our definitions from the shared class library, so we add the reference to it as well to this CS_proj file. And now let's build it to make sure that everything resolves as expected. And we're going to modify the index.razor page, which is our starting page. Again, I prepared this page separately, so we don't have to see me type it out and hit the backspace key too many times. But it's not complete, so we're going to have to add some behavior to it. So let's take a look. We use Bootstrap for the layout. We, of course, have a reference to our common definition that we created earlier. Very importantly, we inject the event bus property, which is the LambdaSharp event bus client, which allows us to talk to the event bridge in the backend. And then we have a, pardon me, we have a simple layout. We simply show Bitcoin price as a heading. We have a reference to an active property, Bitcoin price, which is a string, which we initialize at the beginning with waiting for price. As we wait for an event to arrive, we have two buttons, an upvote and a downvote button that are linked to the corresponding properties that contain a count of the number of upvotes and downvotes we have received. And whenever they are clicked, an associated method is invoked. So now let's add some meat to this implementation. Specifically, we want to emit that an upvote was clicked. For that, we need two pieces of information. We call log event, just like we did in Lambda. It's the exact same design pattern. We're going to create a new class for now. We just have a stand-in. Voter ID is going to be the app instance ID. Every time the Blazor WebAssembly app gets instantiated in the browser, it gets a new GUID, which identifies the session. And so for the upvote, we say vote true. For the downvote, we say vote false. That's it. The next thing we need to, of course, do is actually define the class that we just populated. So we're going to put in the same file as our Bitcoin price event class. And this one has now two properties, the string for the voter ID, which identifies uniquely the application, and then the vote, if it was an upvote or downvote on the current price. Okay, so that takes care of emitting the event when something is clicked. You can also say we have a log info statement, which is going to get emitted to CloudWatch logs. However, we also need to subscribe to the events we want to receive, and that's where we use the event bus, which is part of the LambdaSharp SDK. So this is pretty straightforward. We invoke on the event bus subscribe to, and you can see VS Code and code completion don't play really nice with Blazor pages, so we just have to remember what the syntax is. The first part which I leave out for now is the source of the event, and then we give it a method we want to be invoked with that event when it is received. And because we give it a type, from the type it can infer the event CloudWatch event type and the payload and how to deserialize it. Okay, next I'm going to paste in the methods that we're going to invoke, just to keep it simple again. They're pretty straightforward. So this one gets invoked when we get a price event, which we had defined earlier, and we're going to serialize the price to a string using currency with 2 significant digits. We also need to invoke state has changed. That's really important because otherwise Blazor doesn't know to re-render the contents. Similarly, on vote, we store in a dictionary the vote that we received by voter ID, so that if somebody changes the vote, we can reflect it accordingly. And then we do a simple link expression where we count all the upvotes and we update the upvotes property. So when it's true, and the downvotes when the Boolean was false. And again, we have to call state has changed. So this takes care of everything. Now, the name, every event has a source. And by default, LambdaSharp uses as source the name of your module. So in this case, Bitcoin hot or not, followed by 2 colons, and the name of the actual code, the Lambda or the app that is emitting it. So for our price, it was our Lambda function. So that's the source that we're going to specify, publish Bitcoin price function. And similarly, for the vote, which comes from our app, we're going to specify as vote, the vote app. So these are the strings needed to know which where the events are coming from so we can subscribe to them. However, having them in code here is not sufficient. When I go a little bit more detail into that in a moment. We have also to tell the module that our app can subscribe to these events. It doesn't have to, but it can. So we have to define every single event source that is available to the app explicitly. So now I added Bitcoin price function, and similarly I'm going to add the vote app. Great. So now these 2 sources have been made available to our front-end app. Now these events are happening server-side, but they will get forwarded to our front-end if it decides to subscribe to them. So they only get forwarded when needed. Same as before, we run LambdaSharp deploy. That will recompile all associated project with this module, upload the compiled code, and then initiate a CloudFormation stack update as needed for deploying all the required components. This takes about 5 minutes, so we're not going to watch that happen. Instead, I'm going to talk about what's happening in the background. So this is kind of what we just built with just a few lines of code, as you could see. We have our application here on the left. It's in the browser. The assets for the application, so the DLLs and so on that constitute the Blazor WebAssembly application were loaded from an S3 bucket that was created for us automatically. In addition, there's also an API gateway REST API that can be used for logging. So whenever something happens in the front end, we can see it, and we can inspect what happens on these sessions on the back end. And we have a WebSocket API that is used for pushing notifications to the browser when there are subscriptions. So this gets opened only when a subscription gets established. And it listens to events happening on the event bus, and then depending on the subscription state of the application, may forward them. So event bridge events have been around for a little while, but they have gotten a lot more important more recently because of event bridge. So they used to be just called CloudWatch events. There's quite a few pieces of metadata that are associated with them, but the 3 that are really, really important are the source. This is the application that has been emitting the event. So that was, in our case, the Bitcoin hot or not, : and then the name of the entity, be it the Lambda function or the app. The detail type is kind of like, what type of event is it? That's one app can emit multiple types. So by default in LambdaSharp, that's the full type name from .NET. And then detail contains the actual payload of the event. Out of the box, there's about 40 plus services that actually AWS has that publish into EventBridge. So there's a richness of data, even if you don't publish your own events to begin with, but it's really easy to do so. The second half of working with EventBridge is, of course, now subscribing to events. And that's where the patterns come in. They're also known as rules. So rules have patterns. And as I was showing earlier, we have to specify which event we want to listen to. So you can list multiple constraints for the events you would like to receive, such as the source, which we used, the detail type, which we used implicitly by providing a type to subscribe to. And then, as shown in this example, you can even match on data inside the events. For example, here we told it to only forward events that have a prefix of hello. So EventBridge rules are quite powerful in extracting just the data we want. Each one of these constraints must have at least one condition that is true. So one of the sources has to match, one of the detail types have to match, and one of the detail conditions have to match. When they are provided. If you don't specify them, then it can be any detail type or any detail itself. So EventBridge will then match all incoming events, see if they match your target. If they do, forward them, otherwise block them. So the LambdaSharp app event bus is kind of a piece that sits in between the app and Amazon EventBridge. So as you saw earlier, we specified events in the YAML file that we wanted to be made available. These are the events that are being effectively subscribed to on EventBridge and then published into the app event bus, which is server-side. Applications then can elect to subscribe to some of these events. And you can imagine a common use case being, for example, a chat room where the front end may only be subscribed to some rooms, not all of them, while the backend actually has effectively all events available for all the rooms. It's just a matter of the front end just subscribing to the ones it cares about so as to limit bandwidth and make good use of it. So that's what was built for us in the background. So now let's take a look at the finished product. So for that, we go to the console. The update was complete. Like I said, it took about 5 minutes. One of the outputs is the URL of the website, the bucket that was created for hosting the website. We're going to open 2 instances of it and put them side by side so we can see them communicate. Okay. And so we're still waiting for the price. That triggers once per minute. But in the meantime, we can already vote up and down, and you can see how the scores are being tallied. So as I change my vote, you can see how both browsers are effectively showing the score. And as changes come in, because we registered by vote ID, if I change it, then it rules my previous vote, assign it to the new vote. In a moment, there we go. Now the Lambda function finally triggered and sent over the most recent price. And remember how this is tied into CloudWatch logs, just like the Lambda function is by default. We can actually see what's happening in our front end. So as we were clicking up and down votes, this was being emitted into CloudWatch logs. We can see upvote clicked, we can see downvote clicked, and we can also see the payload that was being emitted to EventBridge that is then being propagated to whoever has subscribed to it, either on the server side, and as a Lambda function could be subscribing to it, or in this case, we built a front end that subscribes to EventBridge notifications. So that's the application we built. So in a nutshell, we built a backend Lambda that fetches the most recent Bitcoin price from an API, publishes to EventBridge. We also built a front end that listens to those prices and publishes its own votes that then other instances of the same application can listen to and react to, in this case by tallying the votes. And we did all of it by having absolutely no server back-end components. It's all 100% serverless. The application is written in Blazor WebAssembly. It runs 100% in the browser. There are no containers, no EC2 instances. We, of course, used Lambda and the backend for fetching periodically the prices. So all of this is only built when it gets used. And the beauty with serverless, when you build applications this way, is how incredibly cost-effective they are. Now, these are the prices as of this recording. And of course, they tend to over time go lower, but so they might be slightly different now. So the cost components, the first one was about 2.5 cents per gigabyte of DLLs that we store on S3. That's the only cost we have associated with Blazor WebAssembly. It's basically how big our assemblies, and they're nowhere near gigabytes. It would take forever to download. Lambda is 20 cents per million invocations. We have our Lambda triggered once per minute. It's going to take a while to reach 1 million invocations. After that, it's execution time, which is also extremely short. EventBridge is about $1 per 1 million events being published. So again, very cost effective for this type of application. CloudWatch logs, where we keep our logs. So LambdaSharp automatically configures all the logs to only retain data for 30 days and then start deleting it. So about 3 cents per gigabyte. It's configurable, so you can have it shorter. And then, of course, we use CloudFormation for orchestrating the deployment of application. We did it from the command line, but of course, it can also be part of a CI/CD process, and that is a free service. So extremely cost effective. You only pay for the parts that you actually use, so basic utilization. So it's a really great way of building these types of application. Everything was done in C#, backend and frontend, so it's a really cool solution. If you want to find out more about LambdaSharp, LambdaSharp.net is the site where you can find everything. This particular example I walked through in this video is on GitHub at LambdaSharp, Bitcoin hot or not, and that's the fully functioning sample, so you can actually see all the parts of it. You can also follow what we do on Twitter, or we have a meetup we do monthly. And then last, if you have any questions, I can be reached on Twitter as well. I hope you enjoyed this. And please take a moment and fill out the survey when you receive it. Thank you.